Right, guys, we have a little add-on to 13.2 day one. I'm going to call it 13.2 day two. What we want to look at today is just a skill, just a conversion skill that you're going to need moving forward. And so the concept is going to be radians. A radian is simply a different way to measure angle measures. We have talked about degrees and everyone's pretty comfortable with that. I know you know radians exist. Your calculator has both modes. We know how to graph this from yesterday's lesson to kind of get a good idea of what different angles look like, how to estimate where they are, whether they're positive, negative, and so on. But what we want to start doing is transferring into radians because that's really the language of math. As you get into pre-calc and calculus, you get away from degrees. So our big point of conversion is right here. Just like when you're converting between feet and inches, you typically would say 12 inches is 1 foot and you build on that. Our conversion is going to be that 180 degrees equals pi radians. So 180 degrees is the same as pi radians. And while you might not have an idea of what a degree is, you know there's 360 of them in one circle, and so you know they're really tiny. If we went ahead and took our 180 and we divided that by pi, we're going to see that 1 radian is about 57.3 degrees. So just to have an idea of how big a radian is, you would have 1 radian would be all the way up to here. Then your second radian might be about here, and your third would be about here. And so it only takes 3.14 radians to get to that halfway mark where it takes 180 degrees. So a radian is a much bigger space than a degree. But what we're specifically learning today is how to convert. So if I have to go from degrees, which is what we're usually used to and starting with now, and I need to change that into radians, keeping in mind that in radians, my answers are going to be what we call exact, and that's going to mean that they're going to be fractions of pi. And so you're not going to have decimal answers. If you have decimal answers, they are not going to be correct. So say I had, for example, 120 degrees, and I know what 120 degrees looks like. It's just 30 degrees past 90. I can draw that out pretty quickly and pretty confidently and say, hey, that's going to be 120 degrees because I have a good frame of reference from my experience with degrees. But if I have to draw it like we're going to have to with radians, I need to be able to convert that. And so using my conversion factor up here, to get rid of degrees, I actually have to put the degree part on the bottom, those of you who are familiar with dimensional analysis, probably in chemistry. And I'm going to put the radian part of my conversion on the top. Multiplying the top and then the bottom, there's nothing to multiply by. You basically have a 120 over 1. I would have this. So that's a fraction of pi, but I also have to have a reduced fraction of pi. So I'm going to look at these numbers and I'm going to allow my calculator to do what it does. Take 180, I'm going to take 120 and divide by 180, math, enter, enter, and find out that that's 2/3. So what that tells me is that this is going to reduce to 2 pi thirds, we call that. So this 120 degree angle is the same as a 2 pi thirds radian angle. So in that other language, that's what that would look like. Let's say I had something like, I don't know, negative 330 degrees. Well, again, I don't care about the negative in this case because it's just a direction telling me to go clockwise instead when I start. But again, I have degrees, so the degree part goes on the bottom, radian part goes on the top. I have my negative 330 pi over 180, and then I'm looking to reduce that, so I let my calculator do its thing. Math, enter, enter. I'm at negative 11 pi over 6. So I don't use the pi when I go to do the reduction of my numbers on the calculator, but I have to remember that it is a part of my answer because I really just simplified this fraction. So again, if I had to draw that, negative 330, I would know to start off in this negative direction and stop 30 degrees shy. So So my angle would be something like that. And that would be a negative 330 degree angle, but that's the equivalent of a negative 11 pi over 6 angle once we start learning about radians now. So in general, if I have degrees, I'm going to multiply by pi over 180 degrees, and that is going to give me radians as a fraction of pi. What if I have to go the other direction? Well, that would be probably more common, because if you're given something in radians and you're trying to figure out, well, what is that in degrees so it seems more familiar to me, you're really not going to do anything drastically different. You're just going to flip your conversion. So if I started with, let's say, 4 pi thirds, and I was supposed to draw that, I don't have a clue where that would go. I don't have any frame of reference. So I'm going to go with my conversion factor, but this time, since I have radians, I need to put my radians on the bottom, my degrees on the top. Now I have pi in both, so those cancel. And all I have left is 4 times 180 over 3. So again, just really a calculator thing. So 4 times 180 over 3 tells me that that's the same as 240 degrees. So if someone told me to go ahead and graph 4 pi thirds, I might not know exactly what to do, but I can convert that and say, okay, I'd have to pass by 90, pass by 180, but stop short of that 270 mark. And so I'm looking at something probably down here. That's a 240 degree angle, but now I'm finding out that's also a 4 pi thirds angle in radians. So one last example, let's say I had negative 7 pi sixths. Okay, same thing, I don't care about the negative. That's just a direction later when I'm graphing. What I care about is that this is radians, so I'll put the radian part of my conversion on the bottom and the degree part on the top. My pi's cancel, and I'll just go to my calculator with what I've got going on here. So I'll have negative 7 times 180, divide that by 6, and it looks like that would be equivalent to a negative 210 degree angle. So when I have radians to begin with, I'm going to multiply by my conversion factor with the radian part on the bottom, the degree part on the top, and I'll end up with degrees. So we'll be using radians a lot in the next few days, and you'll definitely use them through pre-calc and calc. So we just want to get comfortable with how to convert, and then we'll practice over the next days how to graph using radians and just try to become more familiar. Your homework today is a quizzes. It is not an actual quiz this time, so you can use your notes. You can kind of try to make your way through some of the problems together. You don't have to send me a picture of your work because there's not a lot of work. A lot of these will just be on your calculator. But take your time and make sure you feel like you really know what you're doing, because that'll be a good, solid skill for you to have in the future. Have a fantastic day, you guys, and I will see you later. Bye.